So today we're looking at lesson 3, numbers in exponential form raised to a power. So essentially we're looking at raising a power to a power. So for any number x and any non-zero integers m and n, then x to the m power raised to the n power is the same as x to the m times n. So we're looking at when we raise a power to a power, we multiply. So it has an illustration here of why this works algebraically. We have our x to the m power, so that's illustrated m times. And then when we repeat that multiplication n number of times, we end up multiplying. Let's show that with a real-world example. If we have 3 squared raised to the 4th power, you know that 3 squared is 3 times itself. And then we raise that to the 4th power. That means we're multiplying that 3 squared times itself 4 times as a factor. And if you count the number of factors of 3 we have there, we have 1, 2, 3, 4, 5, 6, 7, 8 factors of 3, and that happens to be the same thing as 2 times 4. So we can see that that rule of when raising a power to a power, multiply, will work on an actual number. So if we look at exercise 1, we're raising 15 to the 3rd power and then taking that value to the 9th power. So that is the same thing as 15 to the 3rd times 9, and we can write that as 15 to the 27th. And for exercise 2, we have negative 2, the extra parentheses there because of the negative number being taken to the 5th power. And then that value is being raised to the 8th power. So that is negative 2 to the 5 times 8. And so we can write that as negative 2 to the 40th power. Again, remember that we have parentheses around that because it's negative. So continuing with exercise 3 and 4, we see in exercise 3 that we're dealing with a decimal value. The rules stay the same. So that is the same thing as 3.4 to the 17th times 4 power. And that results in the value of 3.4 to the 68th power. And so you take a look at exercise number 4. You have s to the 17th raised to the 4th power. So the rule for that would then be s to the 17th times 4, which is equal to s to the 68th power. In exercise 5, we have Sarah writing that 3 to the 5th raised to the 7th power is 3 to the 12th. We're correcting her mistake. She has a mistake here because she took her exponents and take a look at what happened there. Did she follow the rule? It looks like she added the 5 and 7 to get 12, but when raising a power to a power, we need to multiply. So to fix her mistake, we need to take 3 to the 5 times 7, and so that is equal to 3 to the 35th power. We're going to skip exercise 6 for now. We'll address that in a different lesson. So we continue looking at raising a power to a power when we have different values together as factors raised to the power. For any numbers x and y and positive integers n, x times y to the n power can be written as x to the n power times y to the n power. So we're kind of sharing that power to each factor. To look at how that works with a regular value instead of or a number instead of a variable, we have 3 times 4, and then we're taking that value and squaring it. that, if we followed order of operations, would give us 12 squared, which you should know is equal to 144. But we can take our new rule here and we can say that 3 times 4 raised to the second power is the same as 3 squared times 4 squared. And that would give us 9 times 16. Take a moment to figure that out. And you'll find that 9 times 16 is also equal to 144. So it works with numbers. It will also work with variables. So for exercise 7, there's a couple of different ways we can write this value. We can multiply first in parentheses and say, okay, this is 44 to the 9th power, which is fine. We also can use the new rule to kind of just share that power of 9 and say, okay, that's the same as 11 to the 9th times 4 to the 9th. For exercise 8, we have raising a power to a power, and so we have 3 squared times 7 to the 4th, all raised to the 5th power. And so again, when raising a power to a power, we want to multiply. So that is 3 to the 2 times 5 power times 7 to the 4 times 5 power. And then we simplify, so that's 3 to the 10th times 7 to the 20th. For exercise 9, we're applying the same rule. We just have numbers and variables involved. And so we have 3 squared times a to the 4th, all raised to the 5th power. Again, here we're raising a power to a power for each of these. So we end up with 3 squared raised to the 5th power, so we would multiply those powers, times a to the 4th raised to the 5th power, so we'd multiply those powers. And so that simplifies to 3 to the 10th times a to the 20th. For exercise 10, we would continue, and then that we're sharing that power, and so we would get 5 to the 7th times x to the 7th. And in exercise 11, we have the same expression with an extra factor of y squared. So we get the same 5 to the 7th times x to the 7th, and then when we're taking a power to another power, we multiply. So that becomes y to the 14th. For exercise 12, we would continue the rule of raising a power to a power, we multiply. So we have a squared to the 4th power. That gives us a to the 8th, b to the 4th power, and c to the 3 times 4, which is 12th power. For exercise 13, we look at that same rule and just take a look at how x to the n and y to the n are related. We would have x to the n power over y to the n power, and so they are related by division.